The other area that when you develop such systems is something which is not normally talked about in textbooks and things, like an aircraft when it flies closer to an aircraft encounters the wake of the leading aircraft, and this could happen in a combat or in scenarios like in-flight refueling and many other cases. Now you want to make sure, especially a fly-by-wire aircraft, because it has got a lot of sensors, air data sensors, which could get affected by the wake of the leading edge aircraft. Because normally what do you do? When you have air data systems, as I said, each sensor measures what is known as the local value of that parameter. And one way of how you ensure that all sensors are working is what you do by cross comparison. And if the two sensors are close to each other, then you are confident that the value of the sensor that you are using for your downstream activities is sufficiently accurate for your use. But once you enter a wake, it could so happen that one vane could see an upward flow and the other one a downward flow, and even a properly working system could be declared as failed because you are using cross comparison as your failure detection technique. So we need to build in what is known as wake penetration resistant features into the air data system, and this again to us was quite challenging because we had to model first of all the wake vortex in the simulator and then look at what is the effect of such wakes on the various sensing elements as well as the engine and the structural elements of the aircraft. So this is something else that we also spent a lot of time and effort, and today I am confident that we have a decent model which we are validating against flight tests by systematically doing flight tests. And again, this is a fairly large amount of work because you could enter this wake from multiple orientations of the follow-up aircraft in relation to the lead-in aircraft. And therefore, you have to make sure that the systems, the sensors, and the flight control laws work adequately well even under these conditions. So this was again a very challenging area that we think. And as I said, it involves a lot of modeling, especially the wake vortex of the lead aircraft, and also fairly accurate models for your airframe, the flight control system, the air data system, and the inverse air data systems.